Hi and welcome to this on maths prediction for the Edexcel Foundation Tier Maths GCSE Paper 2. Enjoy! Hi, welcome to this on maths prediction. So I hope the first paper went alright for you. This is obviously a prediction for paper 2. Now with this prediction, I'm filming it before paper 1 is out, before I've seen paper 1. If I look at the Edexcel paper and I need to update anything, I will try and endeavour to do that, but obviously the exam is on Thursday, so it's going to be quite a time constraint, but I'll try my best to get something out. Now, like paper 1, this is a skills prediction. It's only going to be questions that are what we call AO1, so the basic questions, which makes up about 40 to 50% of the test, which means that all of your other revision, which I'm sure you have been doing, is even more important using this resource. The feedback I've already seen from paper 1, which for me was just now, is that people found this really helpful, and there were quite a few times where questions that came up on this skills prediction came up in the paper, so that's really good to see. The good thing about the skills prediction is I'm able to do a much wider range of topics to help you guys out. So please continue giving me feedback on that. And if, hopefully not, but if you have to resit again in June, then I'm hoping to do the same thing then and maybe expand on it further. So feedback is really, really helpful. As always, this is available on the site. If you go to onmaths.com, and I'm sure a link will appear up there now to click on it. It's completely free of charge. You don't need to sign up at all. You can just get started straight away. If you choose to sign up, then it will save your scores. And there's some other things on the site as well, like our demon questions and mini mocks and topic-based questions. So if you're struggling on a specific topic, they're all on the site. So if you go to the search bit on the site, you can type in any topic you want, and we've got questions on it. So please do visit the site. If you like this video, please click like, and if you want to be the first to know about any of our future videos, including paper 3 predictions, then please click subscribe. I hope you enjoy the video. Thank you. Okay, so we're asked to find two fractions that are equivalent to a quarter. The word equivalent just means equal. So what I'm going to do is just go through these fractions and cancel them down. Now, 3/10, well, we can't really do anything with that. That's just going to stay as 3/10. On B, I can divide top and bottom by 4. So that cancels down to be 1/3. On C, I can divide top and bottom by 2, and then 2 again. So that cancels down to 3/10. So I've not found any so far. Let's have a look at D. 2/8, I can divide top and bottom by 2, so half top and bottom, and that's a quarter. And E, I can divide top and bottom by 2, and then halve it again, and then halve it again. Now, so the two fractions that are the same as a quarter are D and E. Okay, so for this question you need to understand what vertices are. There are 3 properties you'll be asked about, and that's faces, edges and vertices. Faces are like a side of the shape. You can lay your hand flat on a face. An edge you can run your finger along, and a vertice or vertex or vertices, you would hurt yourself. You'd hurt your finger. They're pointy. Okay, so for this one there are 1, 2, 3, 4, 5 vertices at the front. 1, 2, 3, 4, 5 vertices at the back. So in total there are 10 vertices. Okay, so here we're given a value in meters and we're asked to convert it to centimeters. Now I know that 1 meter is 100 centimeters. Now if you think that it's 1,000 centimeters, you're thinking of millimeters. It's 1,000 millimeters but 100 centimeters. So when we have 12.31 of them, we've got to figure out how we get that into centimetres. Well, what do I do to 1 to get to 100? Well, I times it by 100, and that's how you get from metres to centimetres. So 12.31 times 100, and what I can do here is put it into a grid. So we're going to have 12.3, and haven't got enough, 1. And when you times by 100, you move everything 2 to the right, sorry, 2 to the left. So 1, 2, 3, 1.0, so just 1,231 centimetres. To find the range from a list of numbers, you need to do the biggest take away the smallest. So the biggest number we have is 15, and the smallest number we have is 2. So we're going to do 15 take away 2, which is 13. Okay, so for this question we're given a real life scenario where we're buying 6 pencils and 13 rulers. Now the pencils, it says, cost 50p and the rulers cost 40p. So the total price of the pencils is going to be 6, because we're buying 6 of them, times 50. And the total cost of the rulers is going to be 13, because we're buying 13 rulers, times 40. And then to work out the total cost, we add them together. Now this will probably be on the calculator paper, so I'm just going to type that into my calculator. 13 and 40, and I get the answer of 820. Okay, so for this question we're asked to construct a pie chart from the table. We've got a number of frequencies. Now the first thing to do is work out how many frequencies we've got in total. So first calculation I'll make is adding up all the frequencies, and that calculator tells me is 24. Okay, now the problem we have is a circle has to add up to 360, and at the moment all of our frequencies add up to 24, so we've got to find out what we're going to multiply all these frequencies by to get them to add up to 360. We do that really simply by doing the calculation 360 divided by whatever the total of the frequencies are. So 360 divided by 24 on the calculator equals 15. So this 15 here, if we multiply all three of our numbers by 15, we will get the amount of degrees we need each colour to be. So I'm going to add an extra column here and say angle, and I'm going to do 14 times 15, and it's 210 degrees. 7 times 15 is 105 degrees, and 3 times 15 is 45 degrees. And let's just check this. Let's add them up. 210 plus 105 plus 45 equals 360. And then you need to plot it onto the pie chart. Now, I don't have a protractor on this, so I can't physically do it. And to be honest, it's much more helpful to physically print this out, do it on a piece of paper, and get someone to help you use the protractor if you're not 100% sure. That 210, for instance, what I would do is probably draw a straight line down here, like a mini sort of working out line, and do 210 take away 180, which is 30, and do sort of 30 extra degrees, which is going to roughly be there. And don't forget to label them, so that would be red. 105 is just over 90, and I'm just doing this roughly. I'm not even going to use a straight line to show that it's not accurate. And then label that blue, and then check that you've got 45 left over, and hopefully you do, and then label that other. Okay, so we're asked to write 5/9 as a percentage. Now to get from fractions to percentages, what we want to do is get to a decimal first. So to get from a fraction, which at the moment is 5/9, to a decimal, all you just do is 5 divided by 9, because over just means divide. So I'm going to do that on the calculator, 5 divided by 9, and it comes up with 0.555 blah blah blah. Okay, now to get to a percentage, all we do is we times the decimal by 100, so 0.555 blah blah blah. I'm going to keep it in the calculator and I'm going to times it by 100. So times by 100, and that gives me 55.55 blah blah blah. And to the nearest percent, well, this 5 here is going to push the 5 here up by 1, so it's going to be 56%. So to get from a fraction to a decimal, you just divide top and bottom, and to get from a decimal to a percentage, you times by 100. Now we are given a calculator for this question, so the first thing I'm going to do is type in 1.2 on the calculator. The next thing I'm doing is looking for one of two buttons. Now, if you can find a cube button on your calculator, you can press that. Sometimes you've got to press shift or second function on the x squared button. If you can't find it, then if you click the x with a little square normally, and other calculators show it slightly different, it's x to the power of and then a letter or a square, and then you type in 3. So I'm going to do that now. I'm going to press that button and then 3. If you then press equals, if it comes up with a fraction, just press the S to D button on the Casio calculators, and some other calculators show it slightly differently, and you get 1.728. Alright, so we're asked to find 8.9% of 457. So first of all, I'm just going to convert 8.9% into a decimal. So this is it as a percentage, and as a decimal, I'm just going to divide it by 100, and you always do that to percentages to find decimals. So 8.9 divided by 100, and that gives me 0.089. And all I need to do is get my quantity and times it by that decimal. So I'm going to times that by 457 equals, and it says 40.673, and it wants it to 2 decimal places, so that's going to be 40.67. Okay, so to round numbers to 2 decimal places, I always write the number out, so I've got plenty of space, and I draw a line after 2 numbers past the decimal point, so the line goes here. Now all these numbers here are doomed, but before they go away, that number decides whether that 7 gets promoted to an 8 or stays as a 7. The choices are, if that's 5 or more, it pushes the number to the left up, or if it's 4 or less, stays the same. So because that's a 5, that pushes the 7 up, so it's 8.18. But all the rest of the numbers turn to 0. Now because they're past the decimal point, we don't bother writing them. So the answer is 8.18. So for this question, we're just adding like terms. We've got 13x and we've got a 7x. So we add them together. So we've got 13 lots of x and we're adding 7 lots of x. So that gives us 20 lots of x. Now students sometimes write 20x squared. We don't have any x squareds here, and what the student's doing is they're timesing or multiplying the x's together. We've just got 13 lots of x and we're adding 7 lots of x, therefore we've got 20 lots of x. Okay, so this is quite a tricky question. So we've got a set of axes and we're given a line on it, and we're asked to find the equation of the line. So let's have a look at this line. At every point on this line, okay, even points between the lines, at every single point, x is continually changing. If we have a look at the x values, they continually change. So x is a variable, x will just keep changing. But if you have a look at the y, the y is always 3, anywhere on that line. So the equation of the line is y equals 3, because y is always 3 anywhere on that line. So horizontal lines are always going to be y equals something, and vertical lines are always going to be x equals something. Okay, so this question gives you a little bit more of a hint of how to answer it than your exam will. And to answer this question, we're going to find the price per tissue in each box. So the first box is £8.07, but we know we're going to work out our answers in pence. So I'm just going to do 807. And to work out the price per tissue, I'm going to divide that by the amount of tissues. So divide it by 24. So 807 divided by 24, and that is 33.625, so that would be 3 to 2 decimal places, which it asks us to do in the question. The next one, again, I'm going to do the pennies divided by 20, so 683 divided by 20, and this time it works out to 2 decimal places. Don't need to do anything, don't need to round it. And the last one is 623 divided by 15. So 623 divided by 15, and I do have to round this one because it's 41.5 and then 3 recurring, so it's just going to be 3. Okay, the last bit of the question is to work out which one is best value for money. Well, on 24 box they cost £33.63. Sorry, 33.63 pence. Oh, let's try that fourth time. 33.63 pence. For 20 boxes, they cost 34.15 pence each, and 15 tissue box is 41.53 pence each. So the 24 tissue box, or the 24 box, is the cheapest, or is the best value. And in your answer in the exam, you just explain that it's the cheapest price per tissue. Okay, so we're given a pair of parallel lines in the question, these two here, and we've got 3 options of angles inside parallel lines. We have the C angles, which are interior, and they add together to make 180. We have the Z angles, so that either look like that, or perhaps look like that, or something like that, and they're alternate angles. And the way I remember it is alternate is alternate. I just bung a Z in there to remind me. And the last one is ones that look like that, or in this case, I think look like this. It's like an upside down F or an F. And I remember that they are corresponding angles. Okay, I've just bunged the letter F in there to remind me that the F angles are corresponding angles. Now for these two here, these are all equal, and as I said, for this one, the interior angles, they add up to 180. Now a simple check is, well, have a look at this angle here. It's acute and it's 73. If this one is also acute, then chances are it's going to be the same. If you've got one acute and one obtuse, then chances are you take it away from 180. And there's a bit of a check you can do. So this is 73 degrees because it's the same as the top one. And the answer for this one would be corresponding angles. To calculate mean, what we do is we add up all the numbers and divide them by the amount of numbers. Now this is shown as a table for this. Now this 5 here means that there are 5 4s. So a different way of writing this is just 4, 4, 4, 4, 4. Okay, there's 5 4s. Now we could type in into our calculator 4 plus 4 plus 4 plus 4 plus 4, or what we can do is just 4 times 5, and that will equally give us the total of those 4s. Now when we type that into the calculator, we get 20. And we create this kind of fx column, and I always call this column the x. And let's have a go at the next one. So this 10 here means there's 10 5s. So if we were to add them all up, we would get 50. This 5 here means there's 5 6s. So if we were to add up those 5 6s, we would get 30. And similarly, we're just going to times 7 and 8 together because it gives us the answer we want. And 8 times the 2. Now, this 20 here is how many 4s we have. Like, if we added up all the 4s. This is if we added up all the 5s. So what we need to do is add up all of these, which I call the sum of fx. So I'm going to get my calculator out. 20 plus 50 plus 30 plus 56 plus 16, which is 172. Now, that's equivalent to if we had a long list of numbers and we just added them all up. But how many numbers do we have? Well, if we have 5 4s, 10 5s, 5 6s, 8 7s and 8 8s, how many do we have all together? I call this the sum of the frequencies. And we're going to do 5 plus 10 plus 5 plus 8 plus 2, which is 30. So we have 30 altogether. Now, the mean is if you add them all up and divide them by the amount of numbers. If we added them all up, which we did, we get 172, and we have 30 numbers. So it's going to be 172 on the calculator divided by 30, which is going to give us 5.73 recurring, and 2 decimal places, that's 5.73. So the first thing to do for this question is multiply these two together down the table. Then you need to add these up and add these up and divide the fx column by the sum of the frequencies. And you get the answer for this question, 5.73. Okay, so we're asked to find the next term for the sequence. The most important step we do is work out what sequence it is. So we have to add 4 to get from 3 to 7, and then we add 3 to get from 7 to 10, then we add 7, then we add 10. It doesn't seem to be making an awful lot of sense until you realise that the 10 there is the 10 there, and that the 7 there is the 7 there, and the 3 there is the 3 there, and that screams out to me Fibonacci. Now, Fibonacci means you add the 3 and the 7 together to get the 10, then the 7 and the 10 together to get the 17. You add the 2 previous terms, so 10 plus 17 is 27. So to get the next one, we need to do 17 plus 27, and that's going to be 44. So the next term is 44. Okay, so we have oil and vinegar in the ratios of 21 parts oil and 5 parts vinegar. So the first thing to ask yourself with this question is, how many parts do I have in total? So 21 plus 5, we have 26 parts in total. Now, if 5 of them are vinegar, okay, because the order of these in the question matches the order of the ratio, so there's 21 parts oil, 5 parts vinegar, so 5 out of the 26 total are vinegar. Now, a really common mistake is to do 5 over 21. Just don't forget that there's 26 parts in total, not 21, so it's 5 over 26. Okay, so in this bearing question, we need to remember that the north lines are always parallel. So if I extend the line here, that will help me with this question, and we'll see why in a second. So it says the bearing of B from A is 35 degrees. Work out the bearing of A from B. So if it's from B, I'm at B and I'm working out the angle of A. So bearings always start from north and go clockwise. So the angle I'm looking for is this angle here. Now, I know half of it, or I know a bit of it. I know this bit here is 180 degrees because it's a straight line. So really all I need to do is work out this last bit here. Now, thinking back to the fact that the north lines are always parallel lines, we know that the 35 degrees here is going to be the same as the 35 degrees here, and that's because they're Z angles or alternate angles. So the total angle, the total bearing of A from B is just 180 degrees, that straight line on the right, plus the 35 degrees, the angle we know is alternate to the angle on the left hand side. And so when you add those together you get 215. So the bearing is 215 degrees. Okay, so we've basically got this spinner and spun it a number of times. Well, let's work out how many times we've spun it. So it's landed on black 40 times, it's landed on blue 30 times, and it's landed on red 15 times. So we've spun it 85 times. Okay, we've had 85 trials with this spinner so far. Now, with this information, we can work out the theoretical probability, or sorry, experimental probability of it landing on a red. Now, experimental probabilities is basically probabilities we get from doing experiments. Okay, now it landed on red 15 times and we spun it 85 times. So the experimental probability is 15 over 85. Now it says it's going to be spun another 500 times and we have to estimate roughly how many times it will land on a red. And the way we do that is get the experimental probability, which we've worked out from our experiments on the table, which is this table here. And all you need to do is just times that by 500 and that's it. So I'll use my calculator, 15 over 85 times by 500. And it gives me the answer of 88.235 blah blah blah. And I'm just going to round that down to 88. Now it's important you give a whole number for this because it can't land on a red 88.2 times. Now in the exam they are quite forgiving about whether you round it or not in most of the exams, but you'll always get the mark if you do round it. Sometimes I can imagine they could word the question in a way that if you don't round it to a whole number, to an integer, then you might lose a mark. Okay, so first thing, whenever you're asked to solve, always put the lines in. So first thing we need to do is expand this bracket. So we need to times everything in the bracket by the 3 on the outside. So 3 times 6x is 18x. 3 times 12 is 36, equals 234. Next we need to get rid of that 36, so we're going to take away 36 from both sides. Okay, so we're doing 234 take away 36, which is 198. So 18x equals 198. And then we're going to divide by 18 on both sides, because that's a times 18 on the left hand side. So we're going to divide that by 18, and x equals 11. And we could feed that into the original equation, so 6 times 11 plus 12, then times it by 3, that should be 234. There is a different way of doing this. You could have divided by 3 at the first step to get rid of the bracket, and that's absolutely fine as well. Okay, so there are quite a few different ways of doing this question. One way I'm going to show you now, the fact that £1 equals, not very good at drawing euros, 2.23 euros, and we need to get it equal to 2,676, and so we've got to work out how do you get from here to here. Now the way of doing that is 2676 divided by 2.23, and all on the calculator. So we know we've got to times that by 1,200, which is what the calculator told me when I did 2676 divided by 2.23. Now I can check that by typing in 2.23 times 1200, and it gives me 2,676. So if that works that side, it has to be able to work this side as well. So I'm going to times this side by 1,200, which is quite obvious. 1 times 1,200 is going to be 1,200, and that's going to be my answer, 1,200. Now there's different ways of doing it, different ways of thinking about it. What you can think about is to get from pounds to euros, we times by 2.23. So therefore, to go the other way, we're going to divide by 2.23. And so you just do 2,676 divided by 2.23. There's loads of different other ways of doing it. You can do it with ratios as well. Okay, so to work out the area of the circle, we first of all need to remember the formula, which is area equals pi times r squared. Now in this question we're given the diameter, because the diameter is the full way across the circle. So to find the radius when you have the diameter, you just halve it. So we're going to do 16 divided by 2, which is 8. So to find the area, we're going to do pi times r squared. I'm going to get my calculator up. Pi times 8 squared, and it gives me the answer 201.0619 blah blah blah. And two decimal places, that's going to be 201.06. Now a common mistake with this is to put in pi times 16 squared and then halve the answer. That won't give you the same answer. You need to put in the radius into pi r squared. So you always need to halve the diameter. Okay, so whenever we're asked to estimate with a scatter graph, we're always going to start off by drawing a line of best fit. So I'm going to draw my line of best fit, and yours might be different to mine, and that's absolutely fine. Now, it's asking us to estimate the height, and it's giving us the width. And that's really important because the width is up the side. So a common mistake would be to read 17 from the bottom, but the height is at the bottom. So we've got to check the scale first, and it seems like it's going up in 2, so let's just check that. Yep, it's going up in 2s. So what I want to do is draw a line across at the width of 17, which will be roughly here. I'm going to stop when it hits the line of best fit, and I'm going to draw a line down, and I'm going to read off what that is. Well, this scale is also going up in 2s, I think. Yep, it is. So the estimate of the height would be 4 centimeters. So when we're asked to factorize, it will either involve one set of brackets or two sets of brackets. Now this isn't a standard quadratic, it doesn't have an x squared, an x and a number term. So this is going to be a single bracket. And I've got to figure out what I can divide out of this one and this one. Well, I look at the numbers first, and 20 and 35, or any number that ends in a 0 and a 5, is definitely in the 5 times table. There could be a larger one, but looking at it, well, they're both not in the 10 or the 15 or the 20 times table, so I'm going to stick with 5. Okay, the next thing I look at is if there's letters in common. Well, the first term has an x squared and the second one has an x, so there's definitely an x that we can divide out of both of those. Okay, now to fill inside the brackets, I look at the numbers again first, and I look at that 20 and think, right, what is 20 divided by 5? Well, 20 divided by 5 is 4. Then I look at the x squared, and I think, well, I've divided out one of those x's, so it just leaves with x. I do the same with the second term. I think, how many 5's in 35? Well, there's going to be 7. Now this time there's an x and we're dividing by x, so it just leaves 1. Well, 7 times 1 is just 7. So my full answer is 5x brackets 4x plus 7. Now I can check this by doing a quick smiles and rainbows. Okay, and you can expand it in any way that you know how. So that's going to be 20x squared plus 35x. So we know it's correct. Okay, so in this question we're asked to find the density. So the first thing that I'm going to do is just do my little triangle for density. So density equals mass over volume. So to work out density, it's going to be mass divided by volume. Okay, so we need to work out the mass, which is given to us in the question here. So that's going to be quite easy. And I need to work out the volume. So to work out the volume of a prism, which the shape is, we're going to do the area of the cross section times the length. Now let's have a look at the shape. The cross section is a triangle of base 3 and height 14. So area of a triangle is half times base times height, and the length is going to be how 3D the prism is, which is 5. So we're going to times it by 5. So I'm going to type that into my calculator, 0.5 times 3 times 14 times 5, and I get the answer of 105. So to work out density, I'm going to do the mass, which is 246, over the volume, which is 105. So 246 divided by 105, and I get a very long answer, 2.3428 blah 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 blah. So it's to do decimal places, so 2.34 grams per centimeters cubed. Now the grams was the unit of mass, which was given to us in the question, and the centimeters cubed is the volume, because all of the units were centimeters, so the volume will be centimeters cubed. And that's it. Okay, the first thing to realise with this question is it's a Pythagoras question. We've got a right angle triangle and we're looking for the third side, given two sides. Now, the next thing to do is label the sides. So the one opposite the right angle we always label as C. The other two, it doesn't matter, I'll label this A and this B. The formula for Pythagoras is a squared plus b squared equals c squared. And we've got a squared, which is 6.3. We've got a. We don't have b, but we have c. So let's work that out. I get my calculator. 6.3 squared is 39.69, and 11 squared is 121. So if I put my lines in, I can take away 39.69 from both sides. So b squared equals, so 121 take away 39.69 is 81.31. And then I'm going to square root both sides, extend my lines a little bit. So I'm going to square root that answer. So b equals 9.0172 blah blah blah. Once it's two decimal places, so 9.02 will be the answer. Last thing, just to check it, the hypotenuse, which is this one, needs to be the longest side. So our answer was 9.02, and so that is smaller. So chances are it's correct. Right, so we're given a Venn diagram of items of clothes people are wearing, and it's split between blue and red, and obviously neither are on the outside. And it says a person is selected at random, find the probability the person's wearing a red item of clothing. Now, red is both of these values here, so we need to add them together. So 7 plus 4 is 11, and we need to have that out of the total amount in the Venn diagram. That is all of these numbers together. So we've got 11 so far, plus the 10 is 21, plus the 2 is 23. So my answer is 11 over 23. Okay, the way of approaching these questions is draw yourself a quick number line, put the number in the middle, 12. Now, what would the next one down be? Well, it's to the nearest kilogram, so the next one down could have been 11. If it was slightly higher, what's the next one up? Well, 13. Now, to find the lower bound, or the smallest possible weight, all that is the halfway point between what it could have been, the next one down, and what it was. So the halfway point is 11.5. So that is the lowest weight it could have been. Because if it was slightly more, 11.4, it would have rounded to 11. So the standard equation for a straight line is y equals mx plus c. Now m is the gradient and c is the y-intercept. Now to do this question, because we're given it just as two coordinates, all we need to do is find out what m is and then use m to find out what c is. So we're going to do m first, so the gradient, and the formula for the gradient is the change in y over change in x. Now basically, how much did y change between the two coordinates divided by how much x changed between the two coordinates. Now, it's really common to get these mixed up because you're told since you're very, very young, always put x before y. And in this formula, y comes before x. Now, it's the only time that I can remember that y comes before x. So just remember, this is the weird one. So the change in y, well, our two y values are 104 and 83. So it's going to be 104 take away 83. And our two x values are 14 and 11. So it's going to be 14 times 11. Notice it's the second coordinate take away the first one. That's how you get a change. So you're going to do 104 take away 83. And if you have a calculator, use it. If not, just try and do it in your head. And 14 take away 11, which is 3. Now I know 21 divided by 3 is going to be 7, so the gradient is 7. So we've kind of done alright. We can write down y equals 7x plus c, because we know that the gradient is 7, but we still need to find out what c is. And to do that, since we've plotted in the m, what I'm going to do is I'm just going to put in the values of x and y from one of the coordinates, and you can pick either one. Either one should work. So for the coordinates I've picked, which is the first one, I've got 83 is our value of y, and then we've got 7 times the value of x, which is 11, plus c. And all we need to do now is just solve it to find out what c is. So first thing, I'm going to do 83 equals, and then that would be 77 plus c. And I'm just going to take away 77 from both sides. And again, if you've got a calculator, use it, otherwise just do it in your head. So what have we got? 83 take away 77, and hopefully, yeah, it's the answer is 6. And so that's the same as c equals 6. So now we know what c is, so we can write y equals 7x plus 6, and we will write that in our answer as well. Now you can check that by putting in the values here into the equation. So I'm going to do 7 times 14 plus 6, and it comes out as 104, so we know it's the correct value. Now the reason that this works is because m and c for our equation are constants, they're not going to change. Y and x obviously do change as you go across the graph, so you just need to find it for one of the coordinates, since m and c are always going to be the same for this equation, and then you can just roll it out. Okay, so for this question, we need to change this so that it's 1 on the left-hand side. So we've got to think, right, how do we get that 1? Well, we get that 21 and we divide it by 21. And if we're dividing the left-hand side by 21, we've got to also divide the right-hand side by 21. So we get our calculator out and we type in 4 divided by 21. And we'll write this as a decimal. 0.1904 blah blah blah, and it says it wants it to 2 decimal places, so our answer is going to be 1 to 0.19. So to work out the volume of a prism, we work out the area of the cross section and we times it by how 3D the shape is, which we call the length. So we're going to work out first of all the cross section area. Now the cross section is a triangle, so the formula for a triangle for area is half times base times height. So the base of it is 22 and the height of it is 14. So on my calculator I'm going to do 0.5 times 22 times 14, which is 154. And be careful, the most common mistake here is not to halve it, so with the triangle we have to halve it. And so the volume is the area of that triangle times how 3D it is, so 15. As I said, that's called the length. So times that by 15 and we get 2,310. So my answer is 2,310 centimetres cubed. When doing a genuine random sample, you want to make sure that the people you're picking are representative of a population. So if we look at method 1, selecting 30 students who enter the school in the morning, the first 30, there might be a type of student who enters the school early. So that would not be a genuine random sample. Select a class of 30 students in the school. Again, they will all be in the same class, so the same year group, and maybe the same ability. So we'll cross that out. Method 4, select the first 30 students alphabetically. That is quite random, but everyone in the population needs an equal chance of being picked. And if you had a name beginning with Z, then you wouldn't have an equal chance of being picked. So that's not a great one. But method 3, picking 30 students out of a hat containing all the students' names. So you put all the students in a hat, and sometimes a hat is a figurative, just a way of describing it. It doesn't have to be a hat, but for some reason we always say names out of a hat. Then everyone here has an equal chance of being picked, and there's no bias towards a certain group. So my answer for this is method 3. And if you're asked how to do a genuine random sample, names out of a hat, making sure that you have all the students' names in the hat, and obviously you mix it up quite well, then that's always the best method. Okay, the way we solve these is the same as the way we solve equations. Put our lines going down. And what we've got to do, we've got x on both sides, and whenever you have x on both sides, you find the side with the smallest amount of x's, which is the right hand side, and you take that away from both sides. This isn't the only way of doing it, it's just by far the easiest. So 7x take away 4x is 3x, and I haven't really done anything else with anything else, so just fill those in. Now don't forget to put that greater than sign instead of an equal sign. Okay, then we're going to take away the 8 from both sides, just as we would do with an equation. And so 23 take away 8, which is going to be 15. And then we're going to divide 3 both sides. So x is greater than 5. Now it's really, really tempting to put an equal sign in because you've practiced this so much with an equal sign. So always just check your answer, check it's the same sign, because there have been some exams in the past where you got 0 marks if it was an equal sign, even if you got the correct answer apart from the sign. Now I'm going to be using the multiply method for this question. If you've got a different method that works really well, then stick with it, but you do need to know the multiply method for the GCSE. Now the word that probably tricks most people is this one here. Depreciates means goes down. Okay, it means it loses value. So it goes down by 1.7% each year. So to work out the multiplier, you first of all start off with 100%. Now this time you take away 1.7%, okay, because it's going down by 1.7%. You can do that on your calculator or in your head. So 100 take away 1.7 is 98.3%. Then you want to work it out as a multiplier. So you're going to do 98.3%. And you just divide it by 100. And multiply is a posh way of saying decimal. So 0.983. Now anytime I times something by 0.983, it will decrease it by 1.7%. So we've got a car we bought in 1980, and what is it worth in 1985? So that is 5 years. So it's going to depreciate by 1.7% every year. So we've got the 2,245, and if we times it by 0.983 once, that's 1 year. But we need to times it by that amount 5 times. And instead of writing that times 0.983 times 0.983 times 0.983 5 times, I can just do it to the power of 5. You get the same answer. So in the exam, you can just write times 0.983 5 times, and that's absolutely fine. You get the same answer. So 2245 on the calculator times 0.983 to the power of 5, and I get the answer of 2060.553687, blah blah blah. Okay, so because it's money, it's going to be 2 decimal places, so that's going to be 55. Now last thing is just to check your answer makes sense. Well, the car was worth 2,245. it has depreciated, but not by very much. 1.7% is not very much. So it's gone down, and it's lost about, say, roughly £200. So the answer makes sense. Okay, so we're given a right angle triangle, and we're asked to find one of the lengths, but we have a length and an angle. Now, whenever we have this situation, it's going to be trigonometry that we're going to be using. And the first stage of trigonometry is to label the sides. So you go opposite the right angle, and that's labelled the hypotenuse. Then you go opposite the marked angle, that's the one given to you in the question, and that's the opposite. And then you go between the marked angle and the right angle, and that's the adjacent, and that's just the one left over. Next step is we're going to cross out the one we're not using in this question. Now the hypotenuse is 7.3, so that's interesting, we want to keep that. The adjacent is x, so that's interesting, we want to keep that. But the opposite doesn't really have anything next to it. Next we're going to do the SOHCAHTOA. And this is something you absolutely must just learn. Okay, go around the room shouting SOHCAHTOA until you remember it. Okay, it's not given to you in the test, and this is just a collection of 3 triangles. Okay, we're going to pick which triangle we're using. Now, SAW and TOA each have an opposite, and we've crossed the opposite out. So the only one with the adjacent and the hypotenuse is CA. Now, at this stage, you can write cos x equals a over h, substitute it in and solve it. I'm going to do it a slightly different method. I'm going to do it with a triangle. And this triangle, you write, instead of C stands for cos the angle. So the angle is 42. It's always the angle. Then we're going to put A at the top. Now A is just x in this question. And we're going to put 7.3, so the hypotenuse, at the bottom right. Now the way of using this triangle is you times the ones at the bottom to get the one at the top. Now, a little bit of a tip. What I always do is put the number in first, and then times by cos, sine, or tan the angle. Okay. Now the reason for that is sometimes students forget to close the bracket before they times by 7.3. So I'm going to type in 7.3, and you don't even need to type the times button. It'll work anyway. Cos 42, and then close the bracket, and that equals 5.4249 blah 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 blah. And so to 2 decimal places, that's going to be 5.42. Now, last step is just to check it. The hypotenuse is 7.3, so the length that we're finding has to be less than that, which it is. Okay, so we're given the probabilities it will rain on Monday and Tuesday. The probability it will rain on Tuesday is not affected by the probability it rains on a Monday. And we're asked to find the probability it will rain once. So there's 2 different ways it can rain once. Starting here, it could rain on the first day, but then obviously not rain on the second day, because if it rained on the second day, it would have rained twice. Or it could not rain on the first day, and then rain on the second day, rain on the Tuesday. So we work out the probability that it ends up raining on Monday but not on Tuesday, and we just multiply the 2 probabilities together there. So 6 times 2 is 12, 2 times 7 is 14, so that'd be 140. Now I'm not going to cancel that down, and you'll see why in a second. Okay, so I can then work out the other probability, so it's 14 over 20, nice one, times 5 over 7. So we've already done the working out for the bottom, which is 140, and then we need to do 5 times 14, so 5 times 10 is 50, 4 times 5 is 20, so that would be 70. Okay, now, when you're given a choice between either it raining on the first day, on the Monday, or raining on the second day, the word or in probability means add. So you add the 2 probabilities that you found together. Now when we do that, we end up with 82 over 140. And because we are now ready to give an answer, because that is the correct probability, then we can start cancelling it down. So I can halve top and bottom, so that would be 41 over 70. And I'm not quite sure that there's another way I can cancel that down. I think that's the answer. So I'm going to keep it at 41 over 70. Okay, so we're asked to draw this cubic map. So I'm going to get my calculator out and I'm going to type in 0.5 times bracket 2.5 cubed plus 8 and find out what the coordinate is going to be for this point here. And it says 15.81, so 15.81 will be probably too high for us to plot. So I'm going to delete the 2.5 and change it to 2, so that's 12 with that I can plot. And I'm just going to go through this, changing the number each time. So 1.5 will be 9.6875, so 9.6 will probably be around here somewhere. And in the exam I'd probably write these down. I'm not going to for this video, I'll read them out though. 8.5 next for 1. And I'm not going to get these perfect because my pen's not calibrated that well. So 8.06, which will probably be a little bit lower for 0.5. And then for 0, obviously it's going to be 8. Now the reason I put it into brackets is that when you put negatives in, it's a lot easier. Otherwise you can run into complications, especially when you square them actually, rather than square root. So minus 0.5 is going to be 7.9. That's just going to be slightly below. And on your diagram in the exam, they are quite forgiving with this, so as that you have it where you intend to have it. So minus 1 is going to be 7.5, should be roughly there, a little bit higher probably. Minus 1.5 is going to be 6.3, which will probably be maybe about here. And then finally minus 2 is going to be 4. Okay, now the last thing you've got to do for this question is join these up. Now I am not good at this, but I'm going to try my best. With a cubic, cubics kind of look like this normally, or sometimes like that. Sometimes they go the other way, but it will go up and then down and then up again, or down then up and then down again. So just one straight line going through all the points, so one curved line going through all the points, and just don't feather, don't do any of this business, don't come off and then on again, then off and on again. They don't like any of that. Just one line going through all of them. Now I know that 15 point whatever it was is going to be up here somewhere, so I know the last point is going to be above the graph. Okay, let's get started. I've stalled long enough. Now make sure that all of the graph is shown. That's not bad. I had to go a bit wriggly in the middle there, but that would be absolutely perfect to get full marks. I haven't missed out any of the points, and I've plotted the points accurately. Now this seems like a really easy question that you just do 11 divided by 6 and times by 7. The problem that gives us is it basically means if we add a student, it takes longer. Now the problem is that one looks at this question and thinks it's direct proportion. It's not, it's inverse proportion. So if we have a think about, well, let's label the two things. So we can have hours and students. Now H is inversely proportional to the amount of students you have. So H equals K, which is our constant, over S. The hours is 11. And the number of students is 6 in our example. So I'm going to put the lines in and times both sides by 6. So it's 66 equals K, or K equals 66. Then when I go back to this equation here, we know what K is, and K is a constant, so it's always going to stay the same. So it's 66 over the amount of students. So for our example, it says that there's 7 students, so H is going to be 66 over 7. So let's type that in, 66 divided by 7, and I get the answer of 9.428 blah blah blah. So it says it wants it to 2 decimal places, so it's 9.43. Now, way of checking this is it took 6 students 11 hours. So you'd think with 7 students it would take less time, which it does here. So if you don't know or you forget how to do the inverse proportion, just literally times these two numbers together and then get that answer and divide it by this number here. Okay, so for the first thing we need to realise is we've got a bit of a circle, and the whole circle looks something like this. And we've got the radius of the circle, because that goes to the centre, which is 6 centimetres. And we're asked for the length of the arc. Now the arc is this length here, just on the outside here. And an arc is just a bit of a circumference. So to work out the arc length, we need to do the whole circumference, and we need to times it by the fraction of the circle we have. So to work out the whole circumference, we need to do pi times the diameter. Now we're given the radius, so if the radius is 6, the diameter is going to be 12. Then we need to times it by the fraction of the circle we have. Now we've been told that we've got 61 degrees, and in total there are 360 degrees. So as a fraction, that is going to be 61 over 360. So I'm going to get my calculator and type that in. Pi times 12 times, and I'm going to click the fraction button, 61 over 360 equals, and it gives me the answer of 6.38790 blah blah blah. So it's 2 decimal places, that's going to be 6.39 centimetres. Okay, so for this question we need the formula acceleration equals change in velocity over time. So we need to work out how much velocity has changed, where it starts at 0 and it goes up to 150. So it's changed by 150. We need to work out what the time is. Well, it starts at 0 and goes up to 5. So that's 5 seconds have gone past. And so 15 divided by 5 is 3, so 150 divided by 5 is 30. So it's 30 meters per second squared is our answer. Okay, so this question tells us to enlarge shape A by scale factor of half with the centre of enlargement 3 minus 4, and then I need to label the shape B. So when we do a scale factor of something less than 1, between 0 and 1, it means it's going to shrink. So to make this happen, I am going to be connecting all the points with our centre of enlargement, and that's the first thing we'll do. So I'm just connecting all the points with the centre of enlargement. These are called ray lines. Actually, this line here will be exactly the same. I'm going to draw it anyway. Okay, now when it's a scale factor half to the centre of enlargement, it means that if it was, say, 4 diagonals away, it would now be 2 diagonals away. So if I chop this first ray line up, you can see that's exactly halfway here. And this part here is exactly halfway to the bottom right of the triangle, and this point here is exactly halfway to the top of the triangle. So if I connect these up, what colours I have? Let's have black. If I connect these up, then that will give me my new triangle, which I'm going to label B. Let's just check. Well, A was 2 wide by 4 up, and let's times both those by half. That would be 1 wide and 2 up, which is the case for B. Well, I hope you found that video useful. As I said at the start of the video, please check out our website, which is up here, hopefully. And you can do this paper online. The ones on the website, the numbers change. The questions don't, but the numbers change, so you can try it as many times as you want. If you want any feedback on this, or if you want to give any feedback on this video, please click down below and leave some feedback. All of comments I read, and I try to respond to the ones that I'm able to. And if you like this video, please click like, and if you want to be first to know about our paper 3 prediction, please click subscribe. Thank you very much.